Hi, this is Professor Angela Rasmussen from the Department of Electrical and Computer Engineering at the University of Utah. I wanted to mention the difference between Matlab and the hand approximation that we've done. So this is an example from Matlab. We already discussed the operating region. What we notice here is if we did a hand approximation, we would actually find the value here to be 40 dB. The actual value is minus 3 dB less than that, so that's going to be a value of 37 dB. So when we do our hand approximation, we can still do that, and then we know at the places where it's curving, there's going to be a 3 dB difference. So for example, on this one, we see that it curves from up above to below. And so we know the actual value at 100 is not going to be that minus 26 dB. Instead, it's going to be minus 23 dB. Therefore, we can still use the hand approximation, but then we know that the value is still at those corners are going to be slightly off. So this one would be a minus 29 dB. How we can use this then is that we still say that it operates within that region, but we know right at the corners it's not going to be exactly the same value as during that operating region. This is something as a designer you need to be aware of, because the value, instead of 1 volt out, it's going to be maybe 6 volts out at those corner frequencies. And so that is something as a designer is very important to know. So this value as it goes up is going to be 57 dB. And so on. The other thing is if we know we have multiple poles or zero changes at those locations, so in this case we actually have a change from this to here of 40 dB. So we know we have 2 zeros at that location. So instead of 57, for every pole or zero, it's going to actually have an additional 3 dB. So this is actually going to be an additional 3 dB. So we have 6 dB. So this is going to be 54 dB. And that would be the actual value there. So also we need to know how fast is it changing at those corner frequencies. All right, thank you for watching.